All right, we're out here today in Punta Gorda, Florida at one of our project sites. It's a building that we are restoring that took damage from water intrusion. The building is generally constructed of steel columns. Originally it had some steel beams. There are still some steel beams in the building, but the rest of it is stick frame construction with paperback lath and stucco. So what we're going to show you today is some of the damage that was done to the building and the progress that the contractor is making so far fixing and repairing the building. Here on the back side of the building, which is where most of the damage is where most of the restoration work's going on. The building has steel columns, which you can see every once in a while they go ahead and snake the downspouts for the roof gutters down through the columns, the webs of the columns. The backs of the lanais are built with engineered lumber. We refer to them as LVLs in this case. They're laminated beams. They're essentially kind of like plywood, but they're very, very strong. And what you can see is that the water was intruding around the screen enclosures, getting in and rotting out the beams. So we have some pretty significant beam rot damage. Once the contractor uncovered this damage, we realized that the beam had lost so much of its, structural strength and integrity that that the contractor needed to get up some shoring and some dunnage up here in order to support the weight of the joists and get that weight off of the beam, which allows them to facilitate replacement of the beams. The beams are set into steel pockets, which are welded to the steel columns. Most of that is in good condition, and we'll be able to reuse all that, but the beams have got to go. And the other thing we're going to look at too is the rot damage that actually occurred to the joists themselves. So a lot of these joists are going to need to be modified and repaired, which is what the contractor is working on right now on the other side of the building. So we'll take a look at that and show you some images of that as well. If you look at the damage on this LVL beam here that you're looking at right now, this is a really great example of how a lot of what we deal with is kind of tip of the iceberg stuff. And what I mean by that is that this damage is very severe to this engineered beam. But when you look at the photos of what it looked like before the stucco was removed, to the common person, it didn't really look that bad. Just a couple cracks and a little bit of water dripping out, and nobody thought a lot of it until we opened it up and looked at it. We're up here on the lift, taking a look at the condition of the ends of the truss tails for the floor trusses. And what's really interesting, and we'll show you a picture of it, is when we uncovered this from the bottom, when the contractor opened this ceiling up for us to look at it, the trusses look like they're in really great shape. But once you got the flooring off, the decking off, and you uncovered the beam, you can see that water actually came in from the top, from the screen enclosure, rotted out the ends of the trusses. And so a lot of these truss ends, they can't bear weight anymore, and they're becoming unsafe. You can actually look over here, and you can see that we have almost little to no bearing capacity left at all on these trusses, these truss tails. And of course you can see that the beam that they're supposed to be bearing on is also completely rotted out. So once we uncovered that, we had to come up with a design to repair the damaged truss tails using plywood and new lumber, and to replace the damaged and rotted lumber to get that out of there so that it doesn't cause extensive rot to the new materials we're putting in. And we'll show you a little bit of that. Some of that's already been installed on one of the balconies. Both the plywood and the lumber has been installed, and we'll show you some of that from this angle as well. Okay, so these lanais have some storage closets on them. We discovered some some water damage and rot in the plywood there, particularly in the support structure, the trusses underneath those walls. So those walls have been removed. You can actually look right inside the closets right now. And over here you can see how far this water damage extends into the plywood and the material there. So this is your lath, okay? And there would have been a paper backing on this lath. You can see remnants in this black material here is the remnants of the paper backing. The idea was that any water that penetrates from this side, on the outside, wouldn't get through to the plywood. So this water is clearly from, you know, either damage up above, and that's what it looks like because it's rotted all the way up to the top. So water gets in from the top, and then once it's already behind the wall, it doesn't matter how well you construct the stucco or how well you install the stucco. Once you get water behind the paper backing, you're going to get rot and rot damage. And then that damage extends all the way down here into the support structure below the wall for the closet. So there's going to obviously need to be some repairs done here and some new lumber, new materials put in order to reconstitute that. So here we are at a balcony where they have not cut back the decking yet. Only the stucco has been removed, the tile has been removed, and obviously the screen enclosure has been removed. The wrap around the structural beam or column has been removed. But here you can kind of see that that early evidence. As soon as you start uncovering, you can just see how this wood is just, it's nothing. It has no structural integrity left. You can just literally pick this stuff apart with your hand. Now this is the blocking. There was blocking between the truss tails. So what I'm picking apart right now is that wood blocking that was supposed to be here to support the plywood. And then here, this part is the LVL beam, the engineered beam that all of this material was sitting on. And it actually feels still wet to the touch. I mean, it's spongy and wet.
How did it get like this?
The fasteners that were going down into the deck for the screen enclosure, they were allowing water to draw into this location. So you're literally talking screw holes, you know, every 24 inches on center. And this is the amount of damage a tiny screw hole, actually the space around a screw hole, right? Because the screw is still going into a wood substrate. So just that little tiny hole will allow a lot of water into this situation. And then the problem that they had here on this property is that the stucco, once it got behind the stucco, there was nowhere for that water to go. They had no weep screeds on the stucco, which is one of the things we're installing now on this project, is we're installing weep screeds. So once that water got behind that stucco, it was just allowed to sit there against the LVL beams and just rot everything out. They had nowhere to go. So this is one of the balconies where the rotted beams have already been replaced. We've got brand new engineered beams in here, brand new LVLs. We've got new furring on the LVLs. We've got new repairs to the trusses. So if you look at this section here, you can see that the truss, probably about 12 inches or so of this particular truss was rotted, so it was cut out. New blocking was put in. In order to strengthen the truss, we sandwiched the truss with 3/4 inch plywood on each side, had that engineered and nailed off, and then we also, to add just some more bearing capacity and shear capacity at the ends, we went ahead and added 2x4s on each end as well, and had those nailed into the existing top cord of the truss. And this goes back approximately 48 inches, I think, on these. And you can tell, obviously, that this area is pretty tight in here. So the contractor uses a palm hammer, and in order to finish driving these nails, because there's clearly no way you can swing a hammer in this space. But this is sort of what we want to look at. This is what we want to see. Contractor started at this end. He's been working his way down. The repairs on this particular deck are almost complete as far as the structural repairs are concerned. But the goal is that if this were ever uncovered 10 or 12 years ago from now, that it would look the same, right? So the idea isn't just necessarily replacing and repairing the damaged structural stuff, but now once the contractor finishes all the structural repairs to the building, then we really got to start tackling, well, how do we prevent this from ever happening again in the future? And that's where we bring in waterproofing and all of those systems and how the new screen enclosures will get installed and the particulars of that. And but that's for another video, another day. So here at the rear of the buildings, we can see that the contractor has now installed the stucco on the lath and has painted it. There's still some painting work that needs to be done to the weep screed, but you can see that joint now at the bottom of the stucco and where that weep screed is, so that if any water gets behind that stucco now in the future, it'll come out from underneath the stucco and it will drip away from the beam using that weep screed. That will prevent any future water intrusion problems from causing serious structural damage to the LVL, our new engineered LVL beams. Okay, so we showed you some of the damage at the rear of the building caused to the LVL beams, the wood beams, the wood trusses, all caused by water intrusion. Now we're going to take you over to the front of the building where the contractor discovered, after trying to do some stucco repairs, that there was structural damage at the front stair tower. Now this area is all framed in with steel. Steel structure, steel superstructure, and what you're going to find is the same thing. Water got into this area and caused the steel to rust now. Instead of wood rotting, now we've got steel rusting, and we're going to take a look at some of the damage that this has caused. The other things to note too is the source of the water intrusion getting in, mostly caused by improper detailing, improper construction techniques when the building was built, and improper repairs over the last couple years that have not been done correctly. And we're also going to show you a little bit of thermal imagery showing how water is actually leaking back out of the walls that has been intruding into that area. So let's take a look at it right now. Well, only a couple cracks are required really to let a lot of water in. The problem is that the buildings have been painted with what appears to be an elastomeric paint, and then given their general construction, once the water gets in, it has nowhere to go. So it just stays in there and accumulates. We came out and were asked to look at the lanais, the LVL beams at the back, and the rot damage that was going on back there. But then as that project has progressed, he asked us to come out and look at these other items in the front of the building and these stairwells, and I can tell you they're not in good shape. They look, this is the thing that's so deceptive about the work we do, the forensic work, is to the layperson, this just looks like a nice stucco wall. But when you start adding up all of the little indicators, the cracks, the settlement, the bulging of the stucco, the bulging of the building materials, the rust coming out from things, you start realizing that the structural damage is a lot more significant than just a crack or a bulge or a piece of missing paint. Add it all up together, it can mean something really serious. If you look here, you can actually see where we have separation of the wall all along this lower area here. And again, we see a difference in pattern of stucco. Different stucco here than we see above, which means somebody came in here and repaired this at one point. But it looks like the actual only waterproofing they did was just to add this cove joint of caulk. But I mean, look, you've got cracks in the slab below the caulk. You've got separation above the caulk where the new stucco wasn't even brought all the way down. So you're going to get water in there. If anybody ever comes in here and pressure washes this, or if we ever get driving rain in here, you're going to end up with water in that wall.
That puddles.
And I've just been told this deck puddles. What we know about this deck that we're standing on is that it is a steel pan deck filled in with concrete, and that I have steel along this side. What else do we know about steel
when it corrodes.
Yeah,
It expands. So what I see is that we have significant structural damage probably to this side of the pan, and that steel, as it expands, is pushing the facade out away from the building. It's exactly what we witnessed on the other side, with the condition of the steel stud wall and the steel on the other side of the building, or on the other side of this, on the outside, I mean, of this stairwell. So the problem on this landing, we saw that bulge outside. It's going to be the same thing, but in this case, you actually have standing water on the deck. You've got these cracks in the concrete, and you got to remember, underneath the concrete, so the water just soaks right through the cracks, and underneath this concrete is that metal pan. So that water has nowhere to go. It just sits up against that metal, and then it causes it to rust. You can see the kind of the rust damage here already happening to the landing stringer. I'm sorry, the stair stringer where it attaches to the landing. But yeah, this water is just soaking in there, sitting on this pan, because this is a low end of the pan. And the fact that we have sitting water here tells me that this beam that's supporting this landing may have given out, just like on the other side of the building, before even the last project. And that's why maybe this is sitting lower on this side over here. You can't tell that it's sitting lower anymore because they've caulked it all up with this big bead of cove joint material, sealant. But this water tells you that we have a low end here, and the reason we have a low end is probably because this beam is bad. And it's sagged, it's dropped. You can kind of see the orientation of the stairs in the stair tower. Okay, so the landing is toward the street side of the stair tower. And then looking at it here on the side, we have the skin removed from the building because it was exhibiting damage. And you can see where that landing begins over here for that stair landing there. And then right here is your stringer going up for the stairs, which goes up that way. And all of this is supported on this steel beam. And then this steel beam is connected to the steel column on that end, and it's supposed to be connected to the steel column at this end. But when you look at this corner, this connection right here, you can actually see that the beam is not connected at all. So this beam is supposed to be welded and attached to the column. That attachment has given out, and so now this beam is actually bearing on top of this stud wall, which was only ever intended to be an infill wall for lateral, like wind forces. It was not designed to carry the weight of this steel beam and that landing. So the contractor is going to need to get some post shores out here to temporarily support it before we can come up with a repair protocol to actually repair all this structural stuff that's going on here. And on this side, on the right side, you can see we have what we call a bottom plate to the stud wall. And over here on the left, you can see that the stud plate is completely gone. This right here, this is what's left of the stud plate, bottom plate of the stud wall, I mean. Otherwise, the rest of it's just completely gone, completely rusted away. And again, we're seeing more of this on this property where
the contractor, instead of using like a pressure-treated plywood or a yellow board or something like that, actually clad the building in drywall and then put paperback, here's your paperbacking, paperback, lath, and stucco then on both sides of the wall. The paperback, lath, and stucco isn't a bad option, but drywall is not really a good idea. And then if you don't make sure that the wall is properly drained and weeping, you're going to end up with an accumulation of water inside the wall. Now this building has had previous repairs done. You can see that over here. This column here, for example, had been previously repaired and rewrapped. If you come over here on this side, you can actually see the difference in the stucco patterns. And the joint is roughly here. You can actually see where that joint is cracked all along that wall there. And you can see it down at the lower area as well, where this wall has cracked. Where the new repair area and the original stucco meet, it has cracked there. So whoever repaired this column didn't detail the repair very well. And this crack is sort of happening on the outside as well, and it's happening all the way up the building. And that's leading to water intrusion into this wall, which is exacerbating the problem. All right, so the last time we were out here, we were looking at this wall, which is next to this stairwell that's behind me. The contractor had uncovered it from the outside because of some stucco damage that he had found, and we kind of looked at some of that rust damage that was in there and how the water was causing damage. The contractor has removed most of the rest of the stucco and lath that was on the inside, and they've wire wheeled and cleaned up some of the steel columns and things, so we're going to take a look at some of those items. Here you can see this is the structural C channel that was supporting, or is supposed to be supporting, this stair landing at this end. And it's supposed to be attached to this column at this end, and you can actually see this beam is just, flapping in the breeze. So the problem here is that we've lost a significant structural integrity to this superstructure portion of the building, of this stair tower. The stair landing, you can see over here in the corner where the stair landing, it also has a C-channel steel beam that supports the stair landing. That C-channel had a weld plate right here that welded or bolted into this C-channel, and you can see that that connection is just completely gone in there. The water that got into that corner has completely corroded all of that steel away. That connection is bad, and you can see that this steel beam has actually dropped from this steel beam by a good ½ inch or so. We also had the contractor remove part of the ceiling underneath the stairs. We can see that there have been previous repairs to these stairs in the past. Here's a steel plate that was welded on to the riser of the stairs in this location. You can see significant rust damage around the stairs and a lot of problems with that and associated with that. Where most of your water settles in anything, obviously gravity pulls the water down to the bottom, so we're going to expect that the worst damage will be at the bottom of the stair run. You can see that damage here. You can see where this stringer, this riser here on the stairs is completely corroded along the top. It's completely gone along the bottom. Where it attaches to the stringer is bad. The stringer where it attaches to the and sits on top of the C channel is bad. We've got a lot of damage in here. We've got spalled concrete, which is part of our landing. The concrete also contained, this pan contained a steel angle iron. That steel angle iron is completely gone. We can see what's remaining of that, the scaled rust remaining of that angle iron that was supposed to support the pan, which supports the concrete. So without that angle iron, there's nothing supporting the steel pan underneath the concrete. There's nothing really supporting the landing. You get too many people on here, and you could have a situation where this thing collapses on you. Looking over here at the at the steel C-channel beam that supports the landing and where it attaches to the top of this stringer now, you can see that that connection is rusted and scaled, and it's just coming apart. So what we're looking at is a situation where we had on the outside of this wall, we had some basic visual evidence of some stucco problems, right? Contractor opens it up, we find all these structural problems with the wall.
really serious structural integrity issues with the wall. And then we come over here and we look at this wall, and this wall is constructed exactly the same as the other wall. It has the same construction and workmanship defects that are in the other wall, the lack of a weep screed, the lack of proper detailing, the lack of improper repairs that have been done in the past. So we can expect that this wall probably looks like the other wall, and it is also structurally compromised. So what we're going to do in order to fix these stairs is we're going to go ahead and have the contractor, I think these stairs are kind of beyond repair at this point, so we're going to go ahead and have the contractor probably replace these stairs, replace the landing, which will entail having to open up this wall as well on this side, because that's where that stringer is, that's where the landing attaches, and repair this wall as well, at least on the first floor. Now, we don't know what's going on the upper floors, but that's something that we're going to have to meet with the client about, talk about as probably a future project, and it's something that hopefully we'll be able to show you more footage next year or in a few months when that work actually gets done. But for now, we're just tackling the most serious part of this problem, which is the first floor issue. The other thing that we're not going to be able to show you in this video is we're not going to be able to show you the repairs being done, the design work that we're going to put into this, the engineering, what the new stairs look like and stuff. So you'll have to look for that in part 2 of this video series, at least as far as this building is concerned, and we'll show you how all that goes together and how that's put together as well.